Hello all, welcome to Code Hub. Today let us solve the Lead Codes daily challenge. The problem is sort characters by frequency. Given a string or yes, sort it in decreasing order based on the frequency of characters. The frequency of the characters is the number of times it appears in the string. So return the sorted string. If there are multiple answers, return any of them. So the given input string is tree and we have to sort them in decreasing order of their frequency. So E appears two times, T appears one time, and even R appears one time. And when we sort based on their frequencies in decreasing order, E comes first, then T comes first, then T can be the next, and R can be the next. This is a one valid answer, or else E or T is also a valid answer. So this is based on our observation that we want to calculate our frequency, and based on the frequency we want to just sort them in decreasing order and we have to return the string. This is quite simple. Now let us try to code the approach. The constraints are it can consist of both lowercase as well as uppercase characters and digits as well. Even the digits are also valid. So and the length can go up to 10 power 5. So what we can do is we can just store the frequency in a map of MP of 126 characters, which is initialized to 0, and we can first calculate the frequency auto, or else we can have an unordered map of char int MP. This is going to store the frequency, and for auto character in my yes, I have to just calculate the frequencies by frequency of character plus plus. Once it is done, we can just push them into a vector pair int comma char. I will name that to be frequency vector. This is going to store my frequency. So now I will traverse the map for auto ch comma count in my frequency map. What I will do is I will push both into my frequency vector dot push back of count first and then the character. Once I have pushed, now I can just sort them in decreasing order. So frequency vector dot begin frequency vector dot end creator pair int comma char, and this will definitely sort in decreasing order. Once it is sorted in decreasing order, now what we can do is we can just form the string. String resultant is nothing but an empty string initially. Now I can go and traverse the vector for auto ampersand p pair in my frequency vector. What I will be doing is first I will take the count by accessing p dot first. P dot first gives me the count, and character ch gives me the p dot second gives me the character, and I should append count number of times of that character into my resultant. So count minus minus res plus equals to character, and finally I can just return res. So now let us try to run the code. So the time complexity here will be, this was an order of n, this is an order of n operation, then this is an order of n operation, and this is an, let's say, order of m operation. Just the unique digits and characters will be pushed into the frequency vector, and this will be an order of m log m operation, order of m log m operation, and this is nothing but order of n. Actually, you can say it as order of m plus m into order of the count, but it is nothing but order of n. We are just forming the character string. If we are just forming the resultant string, so this is an order of n. So ultimately, what we can say, our time complexity is order of n plus order of m log m, m log m. If it is all unique digits, consider we are having unique digits like 0 to 9, then 26 lowercase characters and 26 uppercase characters, then the vector could have been containing 26 plus 26 plus 10, which is nothing but 62. So this m log m will be reduced to order of 52 log 52, 52 log 52, which is which we can say it as constant. So the time complexity will be reduced to order of n. So that's what we can say. What will be the space complexity? The space complexity is also an order of n. So this is what the time complexity analysis, and the space complexity is also an order of n. Hope you understand the time complexity analysis. Let me format this. Okay, great. Now let us submit our code. Superb, it gets accepted. Okay, can we try to reduce this complexity? Instead of sorting, let us try to do some other approach. Let us try to think of some counting sort approach. But how can we do that? So the time complexity for this approach would be something like R of n plus k log m log m log m. So can we reduce the time complexity here? We can just reduce this time complexity m log m, and we can just do it in order of n using counting sort. Counting sort in the sense we'll use some sort of bucket, which means actually you can see this tree. If we represent this as indices, it is nothing but 0, 1, 2, 3, and obviously you can see that E appears twice. So what does that mean is 0, 1, 2, 3. So at most, if one character, at most every character is same character in the string, then it will be present n times in that string. So what does that mean is we can just use the indices to map their frequencies. So you can say that E appears twice. So we can just map that E. We can just put E to the position 2. Then what we can do is we can see that T and R appears once, so we can just put T at one place and R at one's place. Now you can see that it is nothing but integer is mapped to a list of characters. So while we traversing from this left, we obviously encounter the higher frequency first. So if that particular frequency is having some set of characters, then that many number of times we can just append those characters into our resultant string. So based on this, we can just eliminate this sorting step, which consumes m log m time complexity. So now we can just reduce the time complexity to order of n. So this is a method called bucket sort technique. We are not just actually sorting, we are just appending those characters in that frequency. So we can just have a vector of char of size n plus 1, and I will say it as bucket size n plus 1. We need a frequency, then a bucket, and that's it. Now what we can do is we can just find the frequency first. Once the frequency is found, instead of storing it into one vector, what we will be doing is while traversing the frequency, we will update the bucket. Update the bucket in the sense bucket of count dot push back of character. So now we have the bucket filled. Now we want to form the resultant string. How we can form the resultant string is we can just come from n int I equals to n, I greater than 0, I minus minus. Obviously that character's frequency is not 0 at all, so we can just go till 1. So my count is nothing but the I, or else I will name it as count is greater than 0, count minus minus, and my character ch is nothing but for auto ampersand character in my bucket of count. If some characters are mapped to that count, then what I will be doing is that many number of times, count number of times for auto, sorry, for int for int I less than count I plus plus. Count number of times I will be appending that particular character into my resultant. Hope you understand what I do here. We are having the frequency map and then a bucket of size n plus 1. We are storing the frequency, which is an order of n, and we are just storing the map. We are just storing the buckets. This is an order of m, and we are forming the resultant string. This is an order of n operation, and ultimately the total time complexity reduces to order of n. Okay, sorry, I thought we have to declare the size. I just missed it. Now let us try to run the code. Superb, it gets accepted. Let us use the example test case as well. This bucket sort is quite prevalent in string questions, and hope you can learn from this problem. So it gets accepted. Let us submit. Okay, it gets accepted. Hope you like this solution, and this time complexity is order of n, and the space complexity is also order of n. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.